Welcome to this analytical breakdown of the 50-30-20ths budgeting framework. This presentation is designed strictly for educational purposes to evaluate the mathematical structure of modern cash flow management. Personal finance allocation often presents a complex variable for individuals to solve. However, from a structural perspective, we can normalize monthly income by categorizing all cash outflows into three distinct macro buckets: essential obligations, discretionary expenditures, and capital accumulation. To observe how these percentages interact dynamically across a standard monthly cycle, we will analyze a simulated model featuring a case study subject named Sarah. Let us establish our baseline parameters. In this controlled educational model, Sarah operates as a data coordinator in a metropolitan area. Her net take-home pay, representing total disposable income after tax withholdings, is exactly $4,000 per month. Prior to deploying capital, we must calculate our explicit target allocations utilizing baseline linear equations. First, we isolate the essential obligations, or needs, bucket, targeted at 50% of total net income. Mathematically, this is expressed as 4,000 times 0.50 equals 2,000. Next, we calculate the discretionary expenditures, or wants, bucket at 30% of net income. 4,000 times 0.30 equals 1,200. Finally, the capital accumulation and debt allocation bucket is established at 20% of net income. 4,000 times 0.20 equals 800. Aggregating these allocations accounts for exactly 100% of the monthly income model. Next, we will map Sarah's simulated real-world liabilities against these fixed mathematical boundaries. Let us evaluate the largest component of the framework, the 50% allocation for essential obligations. Within this model, these are defined as non-discretionary liabilities that carry severe legal or systemic consequences if left unpaid. In this scenario, Sarah's primary housing expense is fixed at $1,200 per month. Secondary non-discretionary utility costs, encompassing power, water, and required telecommunications, total $250. Baseline, non-negotiable nutritional consumables are tracked at $350, while baseline health and asset risk management premiums account for $200. Summing these fixed operational costs yields $2,000. The empirical data perfectly matches our target. Actual essential liabilities total exactly $2,000, achieving peak efficiency at the 50% threshold. However, consider a scenario where market volatility introduces a rent increase of $200 in a subsequent simulation cycle. This adjustment drives essential costs to $2,200, shifting the ratio to 55%. To maintain structural balance at 100%, the model demands a proportional reduction in the remaining two categories. This demonstrates how the framework functions as a self-regulating economic constraint. We now turn to the secondary category, the 30% allocation for discretionary expenditures. This is historically where tracking errors manifest, as the variance between subjective utility and absolute necessity can become obscured. In this model, we define discretionary spend as any capital allocation that optimizes lifestyle quality but is non-essential to core survival. Sarah allocates $400 monthly toward social engagements and recreational activities. Media optimization and digital subscription upgrades account for $100. The remaining $700 is amortized toward a travel fund and non-essential apparel. The sum of these allocations is $1,200. This balances precisely at the 30% ceiling of $1,200. The primary advantage of this framework is that it does not restrict capital consumption. Rather, it imposes an absolute mathematical ceiling. If discretionary travel costs rise by an unexpected $200, the model mandates a direct $200 offset in social spending to preserve the integrity of the $1,200 limit. This brings us to the final strategic component, the 20% allocation for capital accumulation and long-term objectives. This category serves as the core financial engine of the model. A 20% allocation against a $4,000 base yields a net monthly target of $800. Sarah bifurcates this $800 into two distinct financial vehicles. First, $500 is routed to a liquid, high-yield cash account to build a robust emergency reserves capital cushion. The remaining $300 is directed into long-term retirement accounts. Extrapolating this data, an annualized savings rate of $800 per month yields a compounding base of $9,600 principal per year. By automating this 20% capital capture immediately upon receipt of income, the model effectively implements a pay-yourself-first protocol, securing future asset growth before lifestyle capital can be depleted. Furthermore, if Sarah's net income scales upward to $5,000, the 20% target scales dynamically to $1,000, preventing lifestyle creep and preserving the macro savings rate. In summary, the 50-30-20th model should not be viewed as a rigid constraint, but rather as a highly scalable mathematical framework designed to enforce structural equilibrium. By analyzing this simulation, we observe how capping non-discretionary liabilities at 50% and discretionary outlays at 30% automatically insulates and protects a healthy 20% capital accumulation rate. Whether deployed via automated enterprise software, custom financial models, or manual ledgers, optimizing these underlying ratios is foundational to advanced fiscal awareness. Thank you for attending this analytical review. If you found this breakdown valuable, please engage with the channel metrics by liking, subscribing, and detailing in the comments below which quantitative financial model we should stress test next. We will see you in the next presentation.